Welcome to the Crazy Hat Chemist. So today we're doing another video on thermochemistry number 17. I can't wait. Bam! So today we're doing a Hess's Law calculation number 2. Okay, this is the given information right here. So I want you to pay very particular attention to this. This is probably the hardest problem that you will ever do using Hess's Law. So you have to look at this here, and the reason why it's difficult, hard, is because there are different states of matter that you need to pay attention to. It's X, Y's, and Z's which you need to pay attention to. There are fractions which you need to pay attention to, and there are 1, 2, 3, 4 different ones that you should be able to add up to get what you want. This is what we want. So we need to somehow add up those 4 equations there, those 4 equations and associated numbers, and then get what we want in that rectangular yellow box. That's what we want. We want that number in that rectangular box. We can't get that number in that rectangular box until we add up those 4 equations. So remember, the rules are as follows. You flip the equation from reactants to products or products to reactants. You multiply the number by -1. If you multiply the entire equation by a 2, you multiply the number by a 2. If you multiply the entire equation by a 1/5, you multiply the number by a 1/5. If you flip the equation from reactants to products and multiply by 1/3, then you're going to do both to that number. That is, multiply by -1 and multiply by 1/3. Okay? So what I want you to do is I want you to pause the video. I want you to try to solve this on your own here. Okay? All right. Let's see what you can do. Give it a try, and then restart the video, and here we go. So, this is what we have right here. In another format here, I've given myself some space so I can write some of these things in the correct order. So, there's no change on this one, and I hope you see that 2Z on the reactant side that's a solid is the same thing as 2Z that's on the reactant side that's a solid on the yellow equation. So this is why we have the correct stoichiometry and the correct order. So there's no change on that one. We don't need to do anything with that one. All right, let's keep on moving down. So the next thing that we're going to be looking for is the X2, X subscript 2, and the gaseous state. And you're going to have to find out what reaction that is in. Okay, and then the next thing we're going to do is we're going to look at Z2Y6 that's a solid and find that and figure out where that is. Okay, now I want you to look at the Z2Y6 that's a solid. It's in the yellow equation, it's on the product side and it has a stoichiometric coefficient of a 1. So can you find Z2Y6 solid in any one of these? It's obviously not going to be on the top one because there's no change on that one. I've dealt with that one. So it's in either equation number 2, 3, or 4. That's right, it's in equation number 2. Having known that, now you can see the Z2Y6, it happens to be on the reactant side, but it does have the correct stoichiometry of 1. So I'm going to flip that equation around. So I'm going to flip this equation. We're going to cross that out. We're going to flip it, and then when we flip it, the equation that is, what do we do the number? We multiply by -1. So that's why we're going to multiply that 230 by -1. So now you should see the the Z2Y6 solid is on the product side with the stoichiometric coefficient of a 1, and that is correct. Okay, now the next thing what we're going to do is we're going to find that X2. Okay, and we're going to find out where that X2 is. It's in the gaseous state. It's on the reactant side. We need to have this in the correct order. Okay, so, oh, by the way, I did make that other equation disappear so we can clear everything up. It will make more sense. I'm going to multiply this equation by 3. Okay, and that will give me my stoichiometry of a 3, which is in that yellow equation. So when I multiply this by 3, I'm going to distribute this 3, and I'm going to rewrite this equation. I'm going to multiply the 175 by a 3. I'm going to get rid of the equation that I crossed out. Okay, so now I've done 2 things here. Well, actually 3. Really no change on the top one. That's why I said 2 things. And then the second one, I flipped. I multiplied the number by a -1. I've multiplied, and then the second thing was to multiply the third equation by a 3, and I've multiplied the number by a 3 and rewrote it. Okay. Now, you should be thinking, well, I got everything I need, but unfortunately you have another equation of which you still have to cross something out with. And this equation is essential to the whole problem because there is something on here that needs to be crossed out, and it is on and you need to cross it out, and you need to work with this and see how you can cross things out. So you should see that in this bottom equation with the numeric value of 570, on the product side there's a 9 x squared y liquid. That's the same thing as what's in the product side on the equation right above that. And you notice that the equation right above that is correct as is written. So what we're going to have to do with this very bottom equation, we're going to have to put that the x2y on the other side, and we're going to have to get rid of the 9 and make it a 3, and we're going to have to multiply by a 1/3. So we're going to be doing two things here on this equation, that is multiplying by 1/3 and multiplying by -1. So we're going to flip it and multiply by 1/3. Therefore, I'm going to cross out this equation, rewrite it correctly, and do the multiplication as is necessary. Once I multiply all my numbers, then I'm going to add them up and then make sure that that number works out well. But before I do that, I'm going to make sure that I cancel everything out and write it correctly, okay, and get what's in the yellow equation. So I'm going to point out a few things here so that it totally makes sense. This 2z, that's brought down. The other thing that's brought down is the 3x2. That's also brought down. Then I have the z2y6. That's brought down. So those are my reactants and products. They're correct stoichiometry. They're on the correct reactant side or on the product side, respectively. Now everything else needs to cancel out. So this z2y3 solid, both of those cancel out. Okay, the next one is the 3x2y liquid that both cancels out. That's important right there too. And then the next one is the 3x2y that cancels out. Okay, and then this next one over here is the 3y2 that cancels out. And I want to make sure that you understand this. This is probably the most difficult part here. And that is on the product side, I have a 3y2 that's in the gaseous state. On the reactant side, I have 2 of these y2s. It's a 3/2. What's 3/2 plus 3/2? That's 6/2. 6/2 is equal to 3. Therefore, they cancel out. Now, I'm going to be able to do the multiplication and add up the numbers, and I'm going to get this fantastic number of 155. This number is positive. This is an endothermic reaction. This is Hess's law. This is the most difficult Hess's law that you will ever do. Maybe. Okay, so I hope you enjoyed that video. And here's another crazy hat. Again, it was from Sean. Thank you very much, Sean, for traveling to a foreign country to get me a hat. I appreciate that. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. I greatly appreciate that. You have a fantastic day. Bye now.